This video will be about the general polynomial expression. So polynomial, we'll call it f, the variable x as its argument. We see a series of coefficients and the variable exponentiated to some power n. N can be 0, 1, 2, 3, or any positive integer. A is a coefficient. It is not a variable, and it multiplies the x to the nth power. Okay, so we use the dots to say, well, this polynomial could be any number of terms. It could be 1 billion terms. Now that's not so outlandish as you may think, and I'll talk about that for a second in a minute. Our last term with the variable is x to the first power. Now x to the first power is just x, right? Oops, that's not good. And the last term is x to the 0th power. And you know that any number exponentiated to the 0th power is just 1. So we can omit this. We can omit this. Okay, so let's take n equals 5. Okay, if we had a 5th degree polynomial, our first term is a of 5 times x to the 5th plus a of 4 times x to the 4th plus a of 3 times x cubed plus a of 2 times x squared plus a of 1 times x plus a naught, or a of 0. Okay, so there's a theory, it's a pretty good theory, it says that you can represent any old function as a polynomial. Now that has lots of restrictions. How good of a fit it is depends on how many terms are in your polynomial. You can also have expressions, polynomial expressions that go that have the inverse of x in them. Okay, so it's not the positive expression is not going to represent completely a function, but as you add more and more terms, you can represent all functions eventually. So polynomials are more useful than they first appear, and one of the problems that students end up having with polynomials is that these a terms, well, to you they may just look like variables, and in some sense they are. But once they're set, they're parameters. And the variable, the only variable in the expression is x. What you set the parameters, a of 5, a of 4, and so on, what you set those parameters to will define the shape of your polynomial. The more terms that you have in your polynomial, the more maxima and minima it will have. Okay, we're going to go over theorems about that very specifically.